Or loud. Okay. So, very happy to be here today with you and to introduce you water quality, the fundamentals, the very basics, like you've been hearing for a long time of these terms. I would like to kind of do the tackling in your mind, so we won't have these gaps anymore. We are going to be very much like emphasize the health issue of water quality and rather than operational and acceptable, just really quickly so you will have it. And please note that I would say that I didn't have time, so no graphics, no men, not a lot of photos, just a lot of content.
Anyway, it's very good to get the picture and to understand what kind of polyform everything was.
Wow, it's weird being on the other side. I can't really hear anything you guys are saying.
So we're going to go through today specifications, parameters and standards, and the WHO standards, and when we have specific standards of IA standards. Going really quickly on our activities, an overview of treatment, just give you an overview because we're going to get there on the treatment processes. The new thing that we're going to go there. Anything else? No, just let's start. Okay, so you like when we classify water, we can classify them as you already know, microbiology and this and that, but in a broader way, we basically classify the water in order like the source of the water and the use of the use of the water. So the source of the water can be groundwater and surface water. In Israel now we're using seawater for drinking because we have the right technology. And the use can be different for drinking, for irrigation, for manufacturing of medical or medicine, and obviously for each one of the users, we need different water quality. The water quality will be different. So why I underline these ones? Because we are using groundwater, we want to be drinking water, and this is like, so I will also try to focus on where we are emphasizing what is relevant for IA activities in water quality, because it's each sentence here is basically be a 3 hours job. Then we have quality classification, also depending on like the use itself when having a water system and distribution system. So we have different parameters. Obviously, we have operational parameters. We have acceptability parameters that have effects but doesn't have health. This is important to remember. We have guidelines and parameters for each one of these specifications, and it will affect differently. So, for example, just an example, iron, which we are having a lot of issues sometimes, it has an acceptability issue because the color is like very, you can see it already in a low concentration. But it doesn't necessarily mean, or doesn't mean that there is health. So it's also a play of like concentration and acceptability, and the acceptability factors doesn't really have, again, health issue, but no one really wants to drink water that are smelly or taste bad. So this is something we will get into what we're doing with IA.
Based on the country standard, is based on WHO, or do we innovation of for the different?
So again, it depends for different parameters. We really focus on health issues, and for health issues, I will also emphasize it. It's not like correct for in the parameter where we are aiming to. For example, turbidity, really quick. Turbidity in Malawi can reach to 10. Turbidity in Malawi, let's say, can reach into 10. Or even 15. We don't accept because we know the effects on the future for our project. Sorry, we will go through it. I just want so there are these kinds of classifications, but then there is the property classification. This is what we are mainly, but it's like another step. Like if we started very broadly, then we went to the different classification, then we have like let's call it the scientific classification.
I didn't get the operational outcomes.
Operational parameters, like let's say these chemical parameters that will affect on the type, on the, for example. So again, it's not necessarily has health effect, but it has some kind of operational effect on our system, and we want to try and avoid it. That's when we're going to, let's say, now, like the water quality here in IA, we have a huge standard in Israel for also an operational point of view. We will try, we are putting them in the end. The most important parameters for us, with health, if we have health issues, this is when we go to review. We won't run away to, like, we won't be very, like to redrill for other operational. Let's say we have some kind of high magnesium and calcium, which is hardness. It doesn't have any effect on the water. It has some effect on the distribution system because it can participate. Like think about updating your boiler.
That's what I had it for.
Yeah. Yeah, because the African water has a lot of carbon and calcium and magnesium. So it comes from the source of the water. Basically,
That's what they added.
now they add it. But they shouldn't be so hard, actually. Originally, it was really hard.
We see the here. On aspect of
So,
Is it true?
just to,
I think you just inferred it also has.
No, no,
okay,
Is it true? Is it true?
don't send the thing today. But this is what I mean, like we will not, like we have an operational issue, we want very quickly, we're not like rushing into treat this operational issue when it comes to water quality. So we have chemical, microbiological properties, and then we have the radiological, radioactive substances. We don't have it, so we're not, like, it's not an issue for IA project, we're not going to get there. Microbiological, we're basically looking for pathogens, like bacteria that actually cause health issues. But not always. Like they can also give us an indicate, like they can be also operational. So microbiological, it both basically you can do mix and match with everything here. So when we're going to give you a little bit into the health hazards, two important things that it's important for you to know when we're dealing with health hazards and water quality. First of all, is that we have a dose. What it means it depends what is the concentration I'm exposed to over time. And also that we have two different types of exposure. Acute exposure means that in very short time you will see health effects. And we have chronic exposure, which means that we're exposed to any contaminant for a long period of time, and after some time we will start to have health effects. So we won't see it immediately. So for example, microbiology, where like pathogens, we're ingesting it in, we're starting like vomiting, we're getting more like some kind of intestinal disease. It's an acute exposure. So we see the health effect quite immediately. Okay, just to have it in mind, it's just an introduction. So, according to the WHO, it's everyone basically water quality. The most common widespread health risks associated with drinking water, microbiological contamination in drinking water, because the effect is acute. Okay, and again, it's a basic, but it's important for you to know waterborne disease is basically diseases that transform in water. And we are like, that's just saying that we have long list of pathogens that are bacteria that have health risks in water that can be transported in water. We won't get into it, obviously. And basically, what we are looking for is for indicators. We start over pathogens, or even one step back. There are microbes all over us, all around us, everywhere you touch, in the air, in the water, everywhere. They are on our skin, on our digestive system. They can be it's all. That is extreme. Not all of them are like having a health effect on us. Not all of them are pathogenic. A lot of them are beneficial, and they are very, very important to the process of the ecosystem of life. Having said that, there are pathogens, and usually when pathogens are like we are the host, the humans or mammals or the best hosts, and we're infecting them, like we're infecting one another. When they are growing in us, they're like this. So when they are like doing something is like so if there is water, not so if we're
water helps to basically transfer this microbes.
so basically the pathogens that are for humans, we are like we are the like if there is a pathogen that I'm hosting, I will infect you very easily because they love humans. They thrive on us. Our body system gives them the best conditions to thrive, to develop, to grow, to multiply. Water doesn't have any food source and doesn't have like the best condition. Our body condition is like 37 degrees. This is like the best conditions for them to grow. So water is not really just a transformative media, one place to another. If the water are contaminated with fecal bacteria,
It came from somewhere from someone.
yes,
Yeah.
yes, someone's food. Exactly. And then it doesn't necessarily mean that there are pathogens there, but this is an indicator for us to know that there is fecal contamination. And this is what we want to avoid all times, actually. Because also, again, it's an acute exposure. So we're looking for indicator bacteria, and I will just make it sure that you already know the indicator bacteria. It's basically, okay, just to say that this long list for each one of these pathogens, we need special media, we need to culture them. If we would start to take it, and it doesn't necessarily mean that they are actually out there. So if we're just taking a water sample and I will look for one of these, and not necessarily find it. So I'm looking for indicator that will indicate me that there is fecal contamination. And this is why we're having the E. coli. It's a genus, it's not just one bacteria, like it's still a family, we won't get into it like all the But basically,
Reut, can you move the computer a little bit more towards you so we can hear you? Because when you're with your back, we cannot hear on Zoom. Thank you.
I will do it like this. It's good now, Hagar?
Yeah, much better. Thank you.
Great. So Escherichia coli or E. coli is the most suitable indicator for fecal contamination. It's important to know whether fecal contamination is of human and of animals. And when I'm saying animals, it's also birds. So when we see this, when we see E. coli, we don't really know if it's human sources or animal sources, but anyhow, we don't want to have it in our water, because that means a source of pathogens. We are less, let's say, I would say it as a side note, birds pathogens are less like affecting us, but other mammals pathogens does affect us. So it's like, it depends on, like, there are mammals that we are sharing the same pathogens with. What is really good with E. coli is that it's rarely found in the absence of fecal contamination. So it means, this is why it's such a great indicator. If we see it, it means that it is
Incubated 44.
45. It's high because, yeah, what you said, because I'm saying 37 degrees.
Yeah.
Yes, but it's basically in order that we can differentiate between them and total coliforms that incubated in 35 or 37.
Okay.
Okay. Total coliform are big.
Where they can incubate in 44 and 45 degrees.
We're not incubating them. Okay. For your question, it's a good question. It's true. Ideally, we will incubate them. We are working on getting like cheap, easy to maintain incubators. But basically, this is why we're using the Aquagenics kit, because it's special. That instead of 24 hours,
with the UV light.
Instead of 24 hours, there is like 40, like you will get results after 48 hours in lower temperature.
Okay.
This is like usually what makes them, this is like the incubating 45.
So if in Cameroon it's really, really, really hot outside and it is 45 degrees, it will be easier to figure it out.
We will see the result faster. Within 24 hours.
Yeah.
Now, total coliforms, they are a big group. I would say for Escherichia coli, for E. coli, the standard is 0. We don't want to see any of them. Total coliform, on the other hand, they are big groups. They are environmental and fecal species, which means that total coliform is not the greatest indicator for.
But when you're saying you want to see 0, like you don't want to see any of them, we are measuring it with the UV light. It's not like with numbers that we are getting. It's not accurate. Yes.
Yeah, but absence of presence. So if there is absence, I'm good. It means it's 0. If there is presence, I'm not happy. Doesn't matter what is the concentration.
Okay.
Like it does matter, but let's say it doesn't matter for this discussion. So the total coliforms are not such a great indicator because there also can be an environmental species, and today we are using them more as indicator for the cleanliness of the distribution system. So it's just that you will know it. Measuring method. As I explained, the water are just a transformative media. We're looking what we're basically, with all the bacteria, they have their own enzymes and so on. We use selective media that enables them, we give them the best conditions for them to strive back. And this is the absence presence, the Aquagenics kit. Okay, when it's becoming green, it means that there is presence of E. coli. And the UV, what you were saying, Omri, we need to move it, is for the total coliforms. So we get in one place the measurement for the two. It's the same for the Petri dishes, the different color.
So it's quite evident to see if there is like if it changed the color.
Yeah.
Because
For E. coli, yeah,
yeah.
very straightforward for E. coli.
Yeah.
That's why we're quite happy with this.
So my team are struggling with the total coliforms.
Yes. Everyone is struggling with the total coliform, not just your team.
Yeah. It's something that you can only see with the UV light.
It's something.
It's just something. Yeah, something like your PhD.
Basically, the total coliforms are another indicator, but they are not indicative of fecal coliforms. They are not indicative of fecal contamination. They are also a group of bacteria. They are kind, if you see here, they are of the same family, basically. So they can be environmental and fecal in the total coliform. So anywhere, it can be many sources actually, because they are also environmental, and they can also develop, like regrow on others, on soil, while pathogens or fecal E. coli, they need us to grow. When you have environmental species, they also, okay, I understand you. No, it also depends. It's just that maybe if we go, it's like you have a family, like we have Cohen, and it's like it can be everywhere, this Cohen. You can find them in Tel Aviv, we can find them in Herzliya, we can find, but then there is a specific Tamar that lives only in Tamar's Cohens, they live only in Tel Aviv. Okay, it's like, so it's just a subgroup. So it's like the E. coli is like a subgroup of the total coliform.
The E. coli is coming from
Fecal contamination.
the total coliform. What are mama kosher as you?
So it can be either fecal because fecal falls down within that, and environmental species that it's not it's not necessarily a source.
Okay.
It's not yeah, exactly. It's like there are microbes everywhere all the time, and so on.
There's no way to control it. That's why the way to prevent it or to protect from the total.
Yeah, no, it's not. No, basically no. Like, but it may indicate, like if we do see them, it might indicate on fecal contamination as well. Like the sources, again, it's like we're talking about our groundwater are deep boreholes. So you actually, you are expecting not to see it. We don't see microbiology in really deep ground. Like they need air, they need their specific, especially pathogenic microbes. They need their conditions. And usually sand is like a filter, like the soil itself is like a filter for them. So if so total coliform may also give us an indication that there is some kind of a way for them to get there to our aquifers. Okay. CFU per 100 ml. I wrote it because you see it always in the lab results, and I want you to, so we have the absence presence and we have the filtering. We are basically growing the bacteria in media on these Petri dishes, and each one of these dots, it's a CFU. Colony forming unit, sorry. So each one of these dots is a colony, because we cannot really see one bacteria, cannot really count one bacteria. One of these dots is a colony that started from one bacteria and grow into a colony. So this is what is CFU basically meaning when you can have it in mind. And per 100 ml, because this is the standard method, we're taking 100 ml of water and we're checking how many colony forming units were there. Okay. So we said it's the greatest risk. We need to find some kind of solution. We have treatment solution. The most widespread treatment solution is a disinfection, is a chlorination, sorry. we use it in the Western world. Our water system are disinfected by chlorination. All of them are working on basically hurting the cell wall of the bacteria and by it killing it. The UV specifically is also infecting the DNA. So this is an illustration of the bacteria, if you haven't got it yet. What is important, the difference, so what we also have the chlorination, we have UV, which is also very common. This is what you have in your tummy arba. Before you drink the water, there is a UV light on a UV radiation that basically makes sure that you don't have any microbes in your water.
So the girls that came here to the office to present their UV treatment, it's not something new.
Yeah, don't.
Tommy Arba.
No, it's not that. But that is because we are talking. Think about tummy arba, such a small. Think about this little tiny hose. That so again, we're talking about dose and intensity. And no, they are actually having a great. They're using leather. There is some. The UV and the chlorine and the chlor is killing. Disinfection with chlorine kills the microbiology. Yeah, it's two different methods to kill the microbiology, and like this is why we say disinfection. We like disinfect the system and our water. The difference between the two of them, first of all, is that we don't have any, like in chlorination, we have some chlorine residues, which is important. So we have them also, this chlorine residue, they stay in the system. They should be very, very low and they stay in the system and then they keep on disinfecting the water for a long time, also during our distribution system. And for UV, there is no residuals. The important when we were like, why it's important to have minimum presence of organic matter. Okay, this is why we are talking with you about turbidity of 5 MTU and less. Think about your sink. It's just for me to remind you to not forget it. When you clean your sink or your toilet, and there is like, I don't know how often you do it, but if you haven't done it for long enough, you have this, you know, this like brownish kind of thing. And once you put it in, it's become all, in a second, it's become white, right? Like the brown sink. You don't know because you are so clean.
Wait. You need to tell us what is the frequency that we need to clean our sink in 2 days?
That's what I'm saying. This is not a take
I want to know from a professional.
It's for you to
doing
visualize.
the right thing. No,
Doing it.
hold on. Is it once a week, once 2 days, once like
Every day.
No, my question was, how often we need to clean the toilet and sink?
After that, let's talk about it after that. What I want to is just when we have presence of organic matter, it basically consumes the chlorination. It's consumed the chlor. This is why I'm telling you think about the sink, because this is a good visualization that to understand how organic matter consumes the chlorine. And this is why we have again the dose, and this is why we don't want to have any turbidity, because the turbidity might have is an indicative for the fact that we might have organic matter and other substances. And then if we're dosing with chlorine, or with the UV, interfere with actually the disinfection process, because we have other particles that consume the chlorine or the UV dose. Is it clear? Like,
Wait, so turbidity?
so think about it like we have we will get into turbidity in a second, but think about it that it's like now we have like Pac-Man, and there is only yellow Pac-Man that eats all the bacteria. The little dots are the bacteria. So we have only one Pac-Man that eats the bacteria. And now we're adding all these fruits and stuff like that, and the Pac-Man wants to eat also other things, not just the bacteria. So something that I just came up with now. So basically now it's like the Pac-Man has like he's eating two things, and we want him to eat only bacteria. We don't want it to eat anything. This is why we don't want turbidity. This is why we don't want organic matter, because we want the chlorine, which is the Pac-Man, to eat only the bacteria. Nothing else pops up. Because the bacteria, yeah, now it's clear? Yes?
So the turbidity symbolizes the
Turbidity is indicative. Yeah, the
Like-
turbidity represents the fruits in this.
okay. So this is for the bacteria to eat, like something that the bacteria can also grow with it.
Okay, I will.
If it's high.
Okay, good. Maybe one step back. We are human. All animals, all creatures. We are consuming. We are having the basic mechanism. We all need carbs and we all need nitrogen. We all need carbon source, which is carbs in our case, and we all need proteins, which is like nitrogen. When you have turbidity, when you have organic matter, it means that you have carbon, you have source for feeding for
For the
for
bacteria.
bacteria as well. Yeah. No, it's not just organic matter, but it's indicative. And if you see turbidity,
means that there is a direct.
that might be an organic matter. Why I'm saying, I'm sorry, I know I'm like, it's part of me did PhD, so for everything, I don't want to say for everything is like, nothing is general, like nothing is correct for all cases. This is why I'm like kind of trying to-
Science and not an engineer.
It's the thing is that with groundwater specifically, we also have this kind of silt, and we have this charsiyot. Charsiyot like doesn't consider to be organic matter. But yes, for the for this for this conversation, yes, let's look at it like that. So think about your sink when you drop the economica, which is chloe basically. You see it consuming like you don't see the consumption of the bacteria, but you do see the consumption of the organic matter by the fact that it's becoming clean. So I'm sorry if I kind of בלבלתי אתכם. But it's important why I'm saying all this, just that you know that we are wanted to start and disinfect our system, so we will have a solution for this problem. Just to summarize that, we have, as you know, new pilots to try it, and the reason that we are asking for 5 NTU for their turbidity is exactly because of that, because it's affecting the disinfection success, like efficiency. So if we have high turbidity, it will interfere with our disinfection. If we have low turbidity, I will maybe try and do it like this and more like instead of all the background in explanations.
Maybe not for today, is also connecting between this and like what the hydrogeologists do, because for example, I know that if there's turbidity, there's more steps they can take, they can do all these things, but like understanding what steps are done to, and it's not necessarily solve, but it's like in the development
Lower
of
the
turbidity.
turbidity.
Like connecting after this, connecting this training. Because now, like I know sometimes we have turbidity, but sometimes we can get low in turbidity and carry on.
Yeah.
Like those
Yeah, but this is just like, generally, and we will get there. Okay, we have a short time, so and I want to also to give you time for questions. So, chemical contamination. There are many chemicals in the water. Not all of them has health issue. They are not necessarily, as we start at the beginning of our talk, there are different parameters. We're just going to focus on which chemicals has health issue. Most of them has chronic exposure. It's a long effect, health effect over a long period of time. The treatment methods that we are currently have for nitrates, fluoride, and manganese, which are what we see in IA, is intensive, economically, energetically, or maintenance-wise. It's not something that we can do. And when they set up the standards, they set up standards to the most sensitive population. So the most sensitive population is usually infant babies and very old people, elderly, just that you know. The main pollutants are nitrates, fluoride, manganese, arsenic, which we're going to talk a little bit today, and heavy metals. Heavy metals should be in a, like, we shouldn't see them. We assess them in the first water quality in the lab. In the first, we usually don't see, they don't see any, like they didn't see any outstanding results for heavy metals. And their limit or their standards is very, very, very low in the ppb parts per billion. And yeah, so we're not going to get into there, but usually if we see them, it's because there is some kind of mining or something like that. We will start with nitrates. However, we have a lot of it in some of our projects. I would say nitrates, again, this is the game. It's not every material is just toxic. Nitrate is very important as a fertilizer to our crops, actually. And the problem that is mechalchel, permeates really, really fast, and it's a tricky way to treat it. And this is why when we fertilize it too much, it reaches into our groundwater. The sources are anthropogenic, urine, fertilizer, wastewater, and when I'm saying fertilizer, I'm also meaning local fertilizer, like not industrial fertilizer, cow manure. If they're spreading it in the field, it can be a source for nitrates. Health risk is the blue baby syndrome. It's basically for infants that under 4 months old. They don't have all the enzymes. We won't get into the mechanism, but basically they don't get enough oxygen in their blood system because the nitrates is taking the place of the hemoglobin. And then they don't have enough, and this is considered to be acute.
Wow. So, how long did you happen?
We will get, I don't want to stress you out also. I will tell you why we can take a big breath and not stress out. It's also a suspected carcinogen. It's not clear yet. Suspected. It means that there is no one clear research. There are some research that showed that it was. There are some research that said that it doesn't. It's not clearly proven that it's so, but the WHO taking extra measures for that, and he doesn't want to take a risk, let's say.
This is one we want to pay attention.
Yes. Everything that I show until now are the ones that we want to, exactly. Nitrates. Measurements are, again, I'm saying for what is relevant for you. We can sometimes see in the lab result as NO3N or as NO3. It's essentially the same. We want to get into this. To move between NO3N to NO3, we multiply by a factor of 4 by 4. So sometimes you will hear me 20, and I will ask them as NO3 or as NO3N, because 20 as NO3N means that it's actually about 100 as NO3. So it's like the WHO guideline is 45 milligram per liter, and this is also the time to say that when you hear milligram per liter or ppm, parts per million, it's essentially the same. So essentially the same, yes. We raised the IA standards to 80. The rationale between that is that Israel, for many, many years, for the last 50 years, before we put in the desalination technology, our aquifers were with our groundwater with very high nitrates. We didn't have that time the way to treat it. This was the standard that was set. It was like this for more than 50 years, and we were okay. So
What years was it lower?
it was until 5 years ago or 6 years ago.
Wow.
So it's higher.
Is 80 like raising the standard or lowering?
It's lowering the standard, raising the allowable
So that's
concentration.
confused because it's not always like the higher the number, the higher it could be the opposite.
Depends in concentration. When you see the unit of milligram per liter,
It means it's a lower risk or higher risk.
higher risk,
Higher risk.
higher concentration.
You get rid of nitrates with desalination?
Yes. I would just say as well but it doesn't matter because in the seawater you don't have so much nitrates. So it's not the issue here when we desalinate is because we want to, yeah. Another way that I want you to also feel maybe less stress about it is that you have to remember the communities that we are handling well with. Most of them are like breastfed and not bottle fed. And when we're saying exposure, then the exposure to high nitrates is if you're bottle fed. When you are less than 4 years, like 4 months.
4 months, yeah.
Much access to
Yeah.
water.
Direct water.
Yes. Yeah. Yeah, exactly. So I would say I feel quite comfortable with these standards that we're raising it for our purposes because we don't have other solution right now. I would mention that we are trying with the BioCastle, it's another desert tech. We will start a pilot with them to see if it will work, and if it will work, we will assess it for this problematic problem. Uganda, some now in Tanzania and in South Africa.
And apart from the, how you call this syndrome? A baby.
Blue baby.
Blue baby. What else? It can cause?
Suspected carcinogen.
What is exactly?
That over long
Can
time
die.
exposure to that you might
Not
have
approved.
CAR, you might develop cancer.
Ah, okay.
Oh.
No, anyway, in Cameroon, I don't know what the average death of like the mortality.
I agree with you.
Like yeah, something like that. So
I agree with you. This is definitely something that we always think, and I would even say more than that. When we chlorinate, sometimes if we don't chlorinate correctly, we might have these residuals that might have also a carcinogenic effect. I don't want to stress you out, but from the chlorine, if we do this, like also here in Israel, but the overview is what is best. What is the options? So the option is that we will have acute, what is less worse? There may be suspectable for carcinogen, for cancer in the age of 70, or to die now because of.
But to have like chlorine, you need to expose to chlorine on like a long period of time. It's not like that if you disinfect the system, so people will
This is what I want you to have in your mind, the chronic exposure.
Yes.
It's not that if in one time or 1 month
It's not
I was
that you are
exposed to.
disinfecting the system with chlorine every
No, but we seem to have
a system, a dose, a chlorine dose. Yeah. But if it's small, no, but if it's in small concentration, like when you're installing the chlorine dose system, it just drops in small concentration. It's not like high enough to, Yeah.
Like overdose, yeah,
Yeah, but then like it's. Yeah,
But
but
when
it's
it's
not all
over,
the
it's
time.
like I want us to move from this discussion. It's two different things. When we're talking about overdose of chloride, no one will
Yeah.
consume the water anyway. We're talking actually about very small concentration that might still have an effect because of the compounds that developed out of it, not because of the chlorine itself. Fluorides, which we have in Limpopo in South Africa, chronic exposure, geological source. Yes. Exactly. So this is the dental fluorosis. On higher concentration, we have skeletal fluorosis. I didn't want to put the photo, it's too hard. So I just, it's that this one. This is what happened to the bone. So this is why I didn't put you a real photo. I wanted just to put an illustration. And yes, thank you, Shir. This is like,
It's funny because everybody in like the Western world wants you to have.
so this is this exactly an example for a substances that in low concentration can be good and in high concentration can cause a lot of damage. And we have it a lot in our life, actually. Like anything, I think it's that, you know, when you have anything is
But
too
if
much,
they
it
will
cause
clean
you
their,
damage.
if they will go to the dentist, like that will be okay.
What do you mean it will be?
She can clean it. Or it's not possible.
No, it's not. It's
Because if you know they are going to the dentist every 6 months.
yeah, but it's not. It's not because you didn't. They didn't. It's really is this staining. It stains
Yeah, but
your.
they can, it's removable, this stain.
No, but it's not, but that it's a sign that the bone is deteriorating. Not
Yeah.
that it's, you know.
But I'm wondering if it's like permanent, these stains.
Not the same can be clean, but it's a sign that.
Yeah, but that's,
something-
but I want to know if it's clean it or not.
It's a joke.
Yeah.
I'm not sure.
Yeah.
About the bone health.
Then the standard is 1.5 milligram per liter, and I don't want us to go higher than that.
Mhm.
With the standard for this.
So again, you want it below 1.5 or you?
I want us to stay with the rule. I don't want to raise the concentration that the people can expose, like
But I'm
nitrates.
saying, when we get our reports, you want the number to be above or below 1.5?
When we're talking about standards, we always want the limit. When we see the number, it's the limit.
Okay.
So we want this or lower.
So if it says 2,
If it says good, so it's a lot above.
meaning good,
No,
Bad.
it's bad.
Bad.
It's above.
like the number needs to be higher or lower.
Yeah, 1.5 is the maximum.
2 and you're screwed.
Yeah, more
But
than
if it
1.5.
was higher, and it says,
No, it's always.
it would be worse.
She is correct in turbidity. No,
In turbidity, it has to be, no, it has to be until 5. If it's 10, it's not good.
No, but in turbidity, you said if it's 80, it's a higher exposure.
Turbidity is
No,
the
it's-
NTU.
NO3. It was NO3, it was nitrate.
Yeah.
And you said 45 is the WHO limit, and then
We're in-
we're agreeing to 80.
We're increasing the concentration.
Yeah. We are saying even if it's more, it's good than WHO. Yeah.
Clinically, always.
Us.
So then it depends if it's our standards or which standard we're referring to. We're referring to IA standard that we have our own internal standard, or we're referring to the WHO
How many
standard.
contaminants do we change? Are we varying from WHO?
And not a lot, just nitrates. And yeah, nitrates actually, just nitrates. Just nitrates for as a health parameter. Okay. Manganese, I would say it is a guidelines. It has a neurological effect. It hasn't been fully studied yet. It's also of geological sources, very abundant in the earth crust. The standard of WH is 0.08. Most countries' standard is 0.1, and this is what we're working with. The way to analyze it is either the lab right now, and this is a good time to say we have the multi-parameter. Some of you heard about the Prime Lab. So the Prime Lab is no more. We're not working with it. It didn't prove itself as a reliable tool, but we just got yesterday a new multi-parameter that I will validate. And if it will be good, we will give it to the water quality specialist, and then they will be able also to measure in-house these three important health parameters: manganese, fluoride, and nitrates.
Like as a technology?
The Prime Lab is just, the technology itself is not new. It's just, I don't know how we come to work specifically with them and not with someone else. I don't know.
So in case that we are starting,
Unfortunately, yes.
in case that we are starting checking it in-house, it means that we won't need to check it in the lab as well. At
So
some
we
point
will,
of time.
at some point of time, I think if we will be really, if our multi-parameter and our staff will be like we will trust the result. Yes, in some point of time, we will send result only when it's above the national limit or something like that to validate it.
So that's what she's saying. So if that stuff and the equipment will prove themselves, so no need.
We have to keep the labs.
One second. Like
Relevant.
you're mixing, it depends on the activity. We'll always go to get a lab report, but the fluoride, manganese, and nitrates, we don't have the way to measure it currently in field, and we're going to monitor. When we're doing monitor, we want to emphasize that we are like strictly concentrating only on health issues parameters. And because right now we don't have the way to measure it in field, we bring the multi-parameter, and I guess it will be like what's happening now with the nitrates. They put the strips. If it's okay, it's okay. If it's above 80%, we take it to the lab. So we will have just another tool to decide if we need to send it to the lab or not. Arsenic, I just want to talk about it really quickly. We don't have it in our project, but it's something that needs to be addressed. Most of the labs are not measuring arsenic except South Africa, but it's considered to be one of the highest risk chemical if it's like there in the water. When?
She's like, that's one of the worst.
Oh yeah, sure, we also have it. No, I think because in Malawi they don't check for arsenic. We just started this new to ask them to measure it. It's of a geological source. Okay, so and the fact that most of the labs doesn't measure it, I don't know why, but what we decide for now, and we also don't see an issue of it, like from studying it studying it. So right now we want to take representative sample from each region for arsenic. So just that you know. And if we're already talking about that, we also want a representative lab sample for a prospective project.
What do you mean?
So if, and not from every project, not from each and every project, we want to take just from like, yeah, we're getting into a new region, yeah, from an open source, just that after that we will be able to show this was the water quality back then, this is the water quality now.
How they are checking for the arsenic?
It's in the lab.
In the lab. Okay.
Okay. I was trying to do it like just for curiosity reasons, thinking the original sources.
How have women still doing that here and there?
So I don't know about the here and there. This is something Sivan asked me like to start and measure it.
There was kind of this PR kick to show what was the, because there was all these, we were still kind of developing this department and trying to understand it from Sivan's perspective, like, well, at least it's so much better than what we're currently drinking and here this comes from.
You know that we had some samples in South Africa that were forced, that the open source was running up and down. Yeah. We were trying to figure out that the water that we were providing the community when they had bad water quality results was, it was like, well, this is better anyways than the open source. So we took samples.
Give me
from the open
a minute.
source.
5 minutes. Like we started 5 minutes later, so. Quickly, we will run on indicative parameters because we heard a lot pH and turbidity and EC. And what we're doing when the EC is much higher, what does it mean? So just to make it clear, there are operational and indicative parameters. What does it mean? It means that they're indicative of the water quality, but they're not giving us the concentration of specific contaminants. Like turbidity might imply means that there may be organic matter. There are some suspended solids. What are suspended solids in the water? It means that it's particles that are small and cannot settle down. So they are suspended in the water. And this is why sometimes they are great media for microbiological growth. Sometimes they are from the operational perspective, like you said before, it can clog the filter and so on. So the way to measure it is with tube, like we brought the new turbidity tube. Not here, it's in the other, and we have the meter. The turbidity tube is supposed to be used for the monitoring. The meter should be used for developing and pumping tests for in-process. The standards are for NTU are for development and for pumping tests, because in development, I guess it's just the development. It's just the very much beginning, and then this is you can still see it. And in the pumping test, you already put all the screens and everything. It's like the well is already there.
The borehole is already.
The borehole is already sealed, and we want to make sure that it's not reaching more than 5 NTU. However, I would say, if like to what Karen says, if there are projects that are 6 or 7 or 8 NTU, we will not say, okay, we're not proceeding. We might put filters, we might put 2 filters, but basically these are the standards. EC, and we measure it in NTU, no metric, turbidity units, doesn't really we need to speak about with it. I'm not sure.
Like extra. Yeah, they flush it.
I just think for us it's useful to know, because we're the ones who are like making sure that the project steps are happening. It's useful for us to understand also when each thing is found, what we need to put into motion.
Okay, so on the water quality perspective, this is what I'm going to talk really quickly. I will wrap it up. EC, we measure it with millisiemens. It's a conductive, like how much ions has electrical balance. We're checking basically ions is like we have solids, we have salt. When we put it in the water, it's dissolved into ions, positive and negative. And we want to make sure that we're basically checking what is the current, how much current is transformed with EC. And this is given an indication on how much dissolved solids we have. And saltiness, but it's not one-to-one. Doesn't mean that if we have IC, it for sure means that there is a lot of salts, like taste salt, chloride. This is why we want to see salinity, I mean. This is why we want sometimes also to test it. We use it with meter, we measure it with meter.
We're just talking about EC, that it's not necessarily an indication of salinity. Handy though, right? But even if it's not salinity, it's still.
There is dissolved solid in the, like that we have components that are dissolved in the water. We have ions in the water.
But is it possible that it's not salinity and it's okay for our purposes, for safety purposes?
So again,
Dissolved solids?
EC and salinity are not, we're finished with the health parameters. We move to indicative parameters, and EC is not necessarily high EC, probably won't pose health effects.
I
Just
recall we've stopped things because it was like bad EC. It was an indicator of salty water.
which is the next, which is the next. I will just, yes. The standards is 2,500 microsiemens centimeters, okay? And then it's like what you were saying. We have the acceptability parameters, color, smell, taste, what we said at the beginning. No one really wants to drink smelly water, even if it doesn't pose health effects on our human body. So acceptability is important, especially in our project, because we want to confirm that the community drinks the water for drinking purposes. But it's important also to remember. But because it doesn't have health effects, to a certain extent, we will try to sensitize it with the community. And to your question with the EC, we kind of have the IEA standards for EC, and when we're going back to the monitoring, what we should do. If the salinity is above 2,500, between 2,500 to 3,500, we want to kind of see how much fluoride there are there, because we do want to put a limit for the fluoride, one of the compositions. But above 3,500, we will take a full lab analysis.
So why am I wrong in that when we drilled and it's high EC, we had to re-drill? Is that because of?
If there is acceptability, again, we need to think in process and completed project.
Right,
And in process, you know, if there is high salinity, we also know that it probably go higher with time and so on. So we said, okay, maybe here, if the salinity is so high, it's better to go and refill. But if there is already a project and the salinity went high, it's a completed project, the community still accept the water, or like doing spacing. There is no health issue. We make sure that there is no health issue. We will try not to really drink it. We will try to sensitize it with the community so they will drink this water. So I guess it's again, it very much depends on where is the status of the project.
Is there a line between the acceptability of EC versus the health at risk?
Exactly. That's the usually with acceptability factors like parameters.
Ruth, I couldn't hear what Yaron's answer was. What was it?
He said usually the flag of acceptability will be raised before even the health risk is there.
Yeah. Ruth, can I ask one question? Why are we measuring EC and not chlorides to begin with? It's because we can't measure that in the field?
Because First of all, we do want to have this indicative. First of all, yeah, chlorides will need to have a specific instrument for it, and EC is a more holistic in a way, I would say. And chlorides, again, they will give us a chloride result, but it doesn't give us the total number of what is going on there. So we're working opposite. If we see a lot of EC that is really high, we want to assess what is composition, and if it's composed of chlorides, we will decide what to do. But if it's composed of magnesium and calcium, it doesn't pose any health effect, so we don't have any issue.
Do our field, we have field sample that will tell us the composition of EC, or just that it's high? And we just send it to the lab.
Just that it's high. Now, just let's go. This is because I feel we run out of time already. Just go quickly on what we're doing in our operations, where water quality, where we are entering water quality during the water project. So we have the drilling, and the drilling we will check EC. This is to prevent maybe high EC after development, to know it in the beginning. We are debating if to add to it nitrates or not. We have the development. In the development, we're measuring for turbidity. And then we have the first disinfection. I know we need to discuss all the procedure of disinfection and the first disinfection and the second disinfection, but basically we have the first disinfection where we need chlorination calculation, high and low chloride, and personal protective equipment. After pumping test, we have the first full fill analysis, which is like all these parameters, and we're taking the first time a sample to the lab, one like sample for microbiology and also sample for physiochemical. And then we have the second disinfection, and the next time that we are going again to the project is for the monitoring purposes. And again, full fill analysis in the borehole. Then we have tank and tap that we're measuring only turbidity and microbiome. I think you're all very aware of what is the procedure. When we're taking sampling to the lab, when the previous result for manganese and fluoride show high, that they are higher than 80% of the national limit. And if NO3 or electrical conductivity are 100% or above when we measure it in field. If the field samples for microbiology return positive, then we all need to go and resample if we think that it wasn't clear, or to disinfect. And I hope soon enough we will have a treatment solution so we can decide, okay, here we need to go.
It's a quick question.
Yes.
I understand this correctly. Out of all the full field analysis that we do, the only ones that are indications of actually sending it to a lab and having real risk is nitrate. If the previous lab, either we don't have it or it's high, or microbiome.
Yeah, for example, turbidity, we have such a good turbidity meter. What will it help me to, it very much depends. We will need to assess it. If I have turbidity, we'll go back and then I will ask, do we have filter? What was, there was rain?
What if you see high iron?
High iron, so iron is a more of an acceptability and operational parameter.
So really those are like the only parameters that we need to worry about for the field test.
Yeah.
Okay.
Can you go back to the previous one? I'm not sure in Tanzania we check all of these during the pumping test. Like usually I think turbidity is checked and then we take a sample to the lab, but maybe I need to verify that.
Yeah.
And every team has all of the equipment for all of those parameters.
No. Okay. As far as I know, am I missing something? Do you know if your team missing something?
Like this is the area.
I think in Tanzania, it's not about missing. I think it's interesting to ask if Dixon knows how to do those things during the pumping test because I'm not sure. I think David Malanda is the one that testing those things. Shit, it's something to really ask. I'm not sure this is happening in the pumping test. I don't think we have full field analysis then.
Yeah. Okay. And yes, just last tracking results. We have our viewing, like water quality view. Just the water quality in process completed and tracker. We are working on the tracker. Will be notified with the help of Shira and Adela. Please just make sure that you have these views, and if you don't have this view, ask Tal to add you.
If you can just like send a reminder to all the water quality specialists to make sure they are filling out these views. Because I'm telling to my team members, like fill out the civil view, the water quality view, but I think that from you, it's also like, just make sure you mention